use geometry and additivity of the definite integral to compute the integral from 0 to 3 of x minus 2 dx. So we will draw the sketch of the line y equals x minus 2 over the interval from 0 to 3. So we'll plot 2 points, x, y. We'll let x be 0 and 3. Then y is x minus 2, so 0 minus 2 is negative 2, and 3 minus 2 is 1. And that gives us 2 points. The points are 0, negative 2, and 3, 1. So those 2 points are on the line y equals x minus 2. Let's plot them. X is 0, y is negative 2. So x is 0, y is negative 2. So this point. And x is 3, y is 1. 1, 2, 3 for x, 1 for y. And we have this line segment here. And we want the integral, so that's going to be the net area between the line and the x-axis. So we have to figure out the area of each of these triangles, and we have to do the negative of this area, negative 1 times this area, plus this area. And in order to do that, we need to know what number this is. In the picture, it looks like it's 2, and that's the x-intercept. Is it actually 2? The x-intercept means that the y-coordinate is 0. So if we come over here and we put 0 in for y, then we get 0 equals x minus 2. So yes, x equals 2 is where the line changes from being negative to positive. So now we can figure out the areas of each of these triangles. The bottom triangle, we need, the integral is going to give us negative 1 times the area, and the area is 1/2. The base of the triangle is 2 units, and the height of the triangle is also 2 units. So the integral is going to give us 2 times 2 divided by 2 is 2, so negative 2. And this triangle, the area is 1/2 the base. The base is 1, and the height times the height is also 1. So this area is just 1/2. And so the additivity of the integral is saying that the integral from 0 to 3 of x minus 2 dx can be split into the integral from 0 to 2 of x minus 2 dx plus the integral from 2 to 3 of the same function. And now, for the first integral, our function is negative, and so the integral gives us negative 1 times the area, which was negative 2. And for the second integral, our function is positive, and so the integral is the area, which is 1/2. So negative 2 plus 1/2 is negative 3/2. So this integral by geometry, and this is the additivity here of the integral. Now we could also solve this problem using the fundamental theorem of calculus. So why not? The integral from 0 to 3 of x minus 2 dx is equal to antiderivative x squared over 2 minus 2x. Plug in the endpoints. 9 over 2 minus 6 when you plug in the 3, and then minus 0 minus 0, and so we get 9 over 2 minus 6, which is 12 over 2. 9 minus 12 is negative 3 over 2, so we get the same final answer. The geometry, though, lets us know that that not only is the net area negative, meaning that there's more area below the x-axis than above, but we also know exactly how much those areas were. One of them was was 2 units below the x-axis, so the area was 2, and the other one had an area of 1/2, and the difference there being -3/2. Here we get that net area, but we have no idea how many regions we were considering and what their areas were.